Episode 13. Sometimes you marveled so much at the beauty of something that you can't help share it with the other people around you. That is the case with math here. I have heard people saying that math is boring. I think if you never developed a good relationship with the math, you would never enjoy it. Math has a unique approach in describing physical phenomenon. Like the phenomenon we will discuss here is gravity. It rarely misses minute details. Here is a story how it explains one more physical phenomena. We take two cases. First, the case 1, it is within the gravitational field. This is the direction of the gravitational field, and we have a sphere which contains a fluid. It's filled up to this point, and this is a pi AB surface we already discussed. Mathematically, a fluid in a spherical container on ground, that is in gravitational field, is a stack of thin circular disks. So, this is a thin circular disk. The thickness of this disk is dB, and any addition or reduction of fluid is equivalent to layers added or removed. So, as we add more fluid in it, its math regards it as this thin surface is added to the fluid, and if we remove it, like it evaporated, it considered this layer removed from the fluid. And there is the second case, case number 2. It is non-gravitational case where there is no gravity. If we take this sphere, this fluid outside in the upper space where there is no gravity, the fluid becomes spherical in shape due to surface tension. Okay, a fluid becomes a sphere under a spherical a fluid becomes a sphere under a surface tension in a non-gravitational field. So, it is the surface tension that makes the fluid in a sphere. Any addition or removal of the fluid is mathematically regarded as addition or removal of concentric spherical surfaces. So, in this case, here is the thin spherical surface which I drew with the pencil line, and the thickness of this surface is dr. So, anytime we add more fluid, it is regarded as the whole spherical surface, a layer of 4 spherical surfaces added to this sphere. So, if mathematically, if we have to calculate the volume, we take the 4 pi r square as the surface area, and we integrate it from 0 to any radius r. The volume becomes 4 by 3 pi r cube. Now let's compare the two fluids. A completely filled up sphere of radius r has same volume of fluid on ground as in zero gravity. So, the fluid, both the fluids, if this sphere is completely filled up, it has the same volume of fluid as it is in the case 2, if both the spheres are of radius r. But there is a difference. The difference is, but the internal structure is different. So, how the fluid is structurally arranged within itself is different. If we freeze it and then analyze its structure, it should have a stack up formation in case 1 as compared to concentric spherical surfaces in case 2. So, here we have to, if we freeze the fluid and then we cut and we analyze its internal crystalline structure or whichever structure it is, the fluid here in this case will be like a stack of layers, and fluid here will be concentric spherical surfaces. So, there will be a different structural difference between the two, and this difference is due to the gravity. There is no other factor involved. After experimentally establishing this fact, we can go on to see how math explains gravity, because the difference between the two structures is gravity. It certainly draws a relationship between gravity and surface tension. It also gives a different picture of gravity than we now know. So, in the next episode we will be discussing the gravity as math explains, or whatever we have learned so far, how math explains to us what is the gravity, what gravity actually is. Thank you.